And that process is called fermentation. So there are two types of fermentation, essentially. There's lactic acid and there's alcoholic fermentation. We're going to look at lactic acid first. So again, this is, what happens after glycolysis when there's no oxygen? Well, nothing from glycolysis can go into the mitochondria. The doors are shut, it's X'd out, it's off limits because there's no oxygen. So what is your body's plan B? Fermentation. So this occurs in, we also call this anaerobic respiration because it's happening without oxygen. And this generally occurs, like a great example would be like on our muscle cells. So I'm pretty sure pretty much all animals, anything with muscular tissue that needs oxygen to cell respirate is gonna have this similar process. But a good one for us is just our muscle tissue. And you know this, you've worked out before and gotten sore, or got a bumped yourself and got a bruise, and you damaged the capillaries in that area, so blood couldn't get transferred as efficiently, and the next day it bruises and it sores. But because of lactic acid fermentation, you didn't have any oxygen in there, couldn't efficiently get oxygen into the area, and you ended up getting a sore spot. So the first part of all fermentation is just glycolysis. Glucose comes in, NAD comes in and starts stripping some of the hydrogens off of it to form NADH, and ADP and a phosphate come in and are transformed into ATP. This is kind of a simplified version from what we looked at earlier in the more details, but you get the idea. The production is NADH and ADP, and at the end we end up with two pyruvates. If we had oxygen, the pyruvates would go into the mitochondria, so would the NADHs. They would just go into the mitochondria. But this is fermentation. There is no mitochondria to go into. Well, there is one, but the doors are shut because they don't have oxygen, right? But through glycolysis, we did produce a little bit of energy. If the body can find a way to keep ATP production going from glycolysis, that's better than nothing at all. But how do we do that? How do we get AT production to keep going? Well, ADP is not a limited resource. There's tons of it in the cell. In this equation, at least, it's essentially unlimited. It's not unlimited, but it's essentially unlimited. There's another thing that we need in order to produce ATP that is a limited resource, and that's going to be the NAD. We need to free up more NAD. The easiest way to do that is to take NADH and take the hydrogen off of it. Doing so, you'll produce NAD. Turns out pyruvate, again, which is 3 carbons, 1, 2, 3, can actually accept hydrogens. So pyruvate comes in, and when he does, he simply just grabs a hydrogen off of the NADH. He takes 2 of them, matter of fact. And when he does, he creates NAD, but he becomes a molecule known as lactic acid. If you look at pyruvate and you look at lactic acid, I know they're moving around the screen, but when you look at them, you notice the only difference is 2 hydrogens there on that the middle carbon. We added a hydrogen to that side, and we added a hydrogen to the other side, to the oxygen. So that's the 2 hydrogens taken from the NADs, taken from the NADHs to create NAD. So the byproduct is lactic acid. That's why it's called lactic acid fermentation. But what we've done, we successfully freed up NADs. So guess what? We can keep going. We can keep glycolysis going. And now, because glycolysis gives us energy, we've got a little bit of energy. It's not nearly as efficient as the rest of the cell respiration in the mitochondria. It's not nearly as efficient as the electron transfer chain in terms of the amount of energy it produces. But again, some energy is always better than no energy, because without energy you're not moving at all. Just not going to happen. So a little bit's better than none. But the problem with this is that lactic acid is an acid, and it builds up inside of your cells. Acids will donate those hydrogens back to the solution in this, around them, and the molecules around them, and they'll start breaking down molecules. Since this occurs in our muscle tissue, it starts breaking down our muscle cells, and that leads to us being sore. So you had a good workout one day, and you're pumping some iron, you're doing good, and later on that day, maybe definitely the next morning, you wake up and you're sore and you can barely move. That's because there's damage done to your cells. and there's still lots of lactic acid in there. It's why it's staying sore. You need to pump out that lactic acid, and the best way to do that is to actually stretch and to work out again. The more you move, the more you're going to pump that lactic acid out of your cells. I have a friend of mine that she's a massage therapist, and she specializes in prenatal massages, but she does deep tissue massages. And if you have if you're like a spot on your back or like a spot on your arm that's super sore, like a knot or something, she's gonna work that knot out, and it's deep tissue, and she'll tell you you built up lots of lactic acid. It causes the muscle to form a knot over time. You just really have to work that knot out because there's a bunch of stored toxins. That essentially, there's a stored lactic acid in there. And as she works it out, she'll tell you this is going to filter out into your system, and it will be, well, your system will start filtering this out essentially, but you're releasing a lot of toxins. So the day you get a massage, you feel a little good after it. The day number 2. You're going to be sore. To put it the way she puts it, you're going to have an attitude, right? So, that's because your body is still filtering out this lactic acid. It's been released the first day. It's being filtered out the second day. Now, on day 3, you're going to pick up the phone and call her and say, whatever you did, do it again because I feel great. And it's true. So, fellas, you want to give your girl a massage? Go for it. Get that deep spot in there. Rub that spot that's going to be giving her trouble. Day number 2, she's going to have an attitude. Don't call her. All right? Day number 3, she's probably going to call you back and go, I feel much better. It's good. If you've ever had a deep tissue massage, you'll understand what I'm talking about. But that's lactic acid. It's not best for your cells, but in a survival situation, it's better to go through lactic acid fermentation to get a little bit of energy than it is to not produce any energy at all. So, what about alcoholic fermentation? Not all organisms go through their plan B as the same way, because not all organisms have muscle tissue. So with lactic acid, with alcoholic fermentation, it's still fermentation, it's still plan B, but this generally occurs in organisms like yeast, the single-celled fungus, for example. And so what happens is it's the same process to start off with. It's all glycolysis. Glycolysis comes in, NAD comes in, takes out some of the hydrogens off of it, becomes NADH. ADP and a phosphate are going to be transformed into ATP. So some energy is being produced, and at the very end, we end up with 2 pyruvates. So because the physiology of a yeast cell is different from the physiology of an animal cell, we still need to free up NADs by taking the H off of NADH. That'll give us more NADs. As long as we got NADs, we can keep ATP production going. But in a yeast cell, there's an extra step. Matter of fact, there's 2 extra steps. The first extra step is we have to reduce down the pyruvate. We need to strip off some of the carbons and oxygens. And in this process, essentially the top carbon and the 2 oxygens it's attached to are simply broken off. And when that happens, we end up getting CO2 gas. We end up getting bubbles forming. This is extremely evident in bread because you put yeast in bread, you fold the dough over it, and you put it in an area that's no oxygen. The yeast will start to break down the glucose in the bread, but they don't have any oxygen, so they go into fermentation. And what do they produce? They produce CO2. CO2 causes the dough to rise. As the gas builds up and expands, it pushes the dough up. So that's when bread rises. That's CO2. That's in there. That's a byproduct of part of alcoholic fermentation. So you're probably thinking, well, I don't want to get drunk off of bread. Well, the process doesn't go that long. It doesn't make that much alcohol, and you'd have to go for a lot longer period of time to get enough alcohol to really have it. But if you ever noticed, beer also smells a lot like bread because they're made from the same process. But once the carbon dioxide is broken off, the pyruvates actually take the form of another molecule called acetaldehyde. Acetaldehyde now is in the form that can also accept hydrogens for the physiology of a yeast cell. So that acetaldehyde will pick up some of the hydrogens that were dropped off by the NADHs, and that will free up the NADs so we can keep glycolysis going. But when you add 2 hydrogens to an acetaldehyde, you get a molecule that's called ethanol. So It's also called ethyl alcohol. There's a couple other names for it, but it's just ethanol. The problem with this is a little bit more serious than lactic acid. Ethanol is a toxin. It will kill you in too great amounts. That's why when you look at a bottle of alcohol, there's a warning label on it. It's poisonous, it's toxic. In small amounts, it has an effect on our physiology. We know this is inebriation. You get a little tipsy, you get a little drunk, and you act like an idiot. You have a good time. And traditionally, we humans know a lot about fermentation because obviously a lot of our social situations are based on or include the consumption of alcohol because it is a relaxer for us. It's just the effect that it has on our physiology. But too much can have a bad effect. You can get too drunk. It can inebriate you can get inebriated, and it inhibits your ability to function. Also, because it's a toxin, it can damage to your kidneys and to your liver, and that can, so people that chronically drink are constantly processing this toxin, which is not good for them, and it can lead to necrosis of the liver. So you got to be careful of this stuff. But yeah, essentially, this is alcoholic fermentation. So whenever you are going to create something like wine or beer, you set up this process. You put a solution of water and sugar, whatever sugars you're going to use, grapes if you're going to make wine, barley, wheat, rye if you're going to do something else like beer. And then if you're going to make it some type of liquor, you'd put other things in there based on where you live. So like tequila is made from agave, potatoes become vodka, sugarcane becomes rum. Rice becomes sake. There's all different things you can use in there. But anyway, it's the same idea. You're just putting some sugar source in there. You put yeast in there with it, and the yeast will start breaking it down. But you have to make sure there's no oxygen. So you have to fill that liquid level all the way to the top and then cap it up with no air in it. Because if there's air in there, if there's oxygen, it's going to rot. It's going to digest the sugar rather than ferment it's not going to go through fermentation. So then you have to put a valve in there because as this starts to happen, the CO2 that's released can build up, and if you don't have an escape valve for the gas, it could cause the cork to pop out, and then oxygen would get in, and you ruin the process. So you have to put an escape valve in there, and usually they just put a tube in, they run the tube out, and that tube goes into a bucket of water. So as the CO2 comes out, it bubbles up in the water. Oxygen cannot get back in because the opening of the tube is in water. And you let that run for about a year and a half. For wines, at least, you would go about that long. And during that time, the yeast is going to start really fermenting and producing a lot of ethanol as a byproduct. And once the level of ethanol reaches anywhere between 10 and 13%, that level of alcohol is enough to kill the yeast, and fermentation stops. So beer and wine is not as intoxicating as liquors because it by nature it just cannot have more than 12 to 13% alcohol. Now liquors, how do you get a higher? That's obviously they have a lot more alcohol in them, or a lot more ethanol in them. So how do you get that higher? You have to distill it. Essentially, you can boil off the alcohol at a lower temperature than water boils. So you just heat the solution, the alcohol boils off, it goes through a condenser tube, condenses back down to a liquid, and you collect that, and you have a distilled liquor. And this is what, like vodka, rums, Jack, anything else, any other type of alcohol, that's how it's made. You want to double distill it, go ahead. It's going to purify the product a little bit more. You can let it age. Usually they put stuff inside of wooden barrels. The sugars inside of the wood will be pulled into the liquor and adds flavor to it. For example, lots of rums are aged in cherry barrels because that natural cherry flavoring will get into the alcohol a little bit. It makes it nice. That's will char the inside of the barrel to open it up, give it more surface area, and that's what makes a lot of dark liquors are dark. So the more it's distilled, or the longer it's kept in a barrel, rather, the darker it will become. And yeah, there's all kinds of processes that go along with this for making alcohol. Again, our society has a large base around the consumption of alcohol, and it's fine as long as you're doing so responsibly. So if you're going to drink, have a drink, but don't be an idiot. Don't consume too much. It's a toxin. Also, it's going to make you inebriated, and the last thing you're going to do is get in a car wreck and kill your friends because you drank too much.